Hey, welcome back to your favorite Fundamentals of College Math class. We're going to take a look here at subsets today. So here's our objectives. So let's talk about first our subsets and the notation there. So set A is a subset if every element in A is also an element in set B. And of course, that would mean not a subset. Okay, so for example, if you've got set A, we got 1, 3, 5, 7. I just need to check if this is truly a subset. Is 1 in set B? Yes, it is. Is 3 in set B? Yes, it is. Is 5 in set B? Yes. Is 7 in set B? Yes, it is. So every element in set A has got to be in set B. So yes, this is a subset. Okay. Next one. Set A is X such that set of elements X such that X is a letter in the word approved, right? So you have P, R, O, O, F if you were to write this out in roster method. And the question is, and here's set A, here's set B, Y such that Y is a letter in the element roof. So you got R, O, O, F. So I say, well, first of all, is P in set B? Nope, it's not. So this is not a subset, right? A is not a subset because P is not in B. Now, if it was the other way around, if we had B is the question, is B a subset of A? Is every element in B? R is in set A. Is every element in B? Yep, there it is. Every element's in A, and then F. Sure enough, every element in B is in set A. So B is a subset of A, though. Okay, but A is not a subset of B, right? Again, every element here has to be in there. Okay? And yes, they can be the same set as well. You know, let's say set A, set B is 1, 2, 3. Is A subset of B? You bet it is. One's in one there, two's in B, three is also in B. So yeah, they can be the same one. And sometimes you might think about with the subset, you know, when it's got the line under it. So yes, they can be the same. Kind of like an or equal to, if you will. All right, a proper subset. So A is a proper subset of B. If set A is a subset, so first of all, it's got to be a subset. Number one, it's got to be a subset, and sets A and B are not equal. So they cannot be the same set. So in other words, A is going to be like smaller than B, right? There's going to be more elements there because everything's in here's got to be in here, but they just can't be the same set, right? So for example, if I go back to 1, 2, 3, 1, 2, 3, you know, A is a subset of B, but it is not a proper subset because they're the same set. They can't be the same set. So again, to be a proper subset, you have to be a subset first of all, but you cannot be the same set. Cannot be the same set. So here we go. Let's look at this one here. A set of all elements X such that X is a person and that lives in San Francisco. So X is people who live in San Francisco. B is a person that lives in California. So the question is, first of all, are they a subset? Does every person that lives in San Francisco live in California? Yes. So we say, okay, that's a subset. And then to be a proper subset, we say, first of all, it have to be a subset, check mark, but they can't be the same set. Yes, there are definitely people that live in California that are not in San Francisco. So they are also a proper subset. So A is also a proper subset of B on this, right? Now, next one, 2, 4, 6, 8. So 2, 4, 6, 8. Okay, every element in A is in B, so it's a subset, but it's not a proper subset, right? It's not a proper subset because they're this exact same set. They're the exact same set. So that one's just a subset. All right, the empty set is a subset. So for any set B, the empty set is um, not a proper subset of B. For any set B other than the empty set, then the empty set is a proper subset of B. Okay, so let's look at let's talk about the number of elements in a set. Okay, so first of all, if we have no elements, if you could list all the subsets of that, and you say, well, the only one is self. So there's only one that's a subset. Let's say we take another subset and we just have one element in it. Okay. So if I have a set with one element in it, how many are subsets? So I say, well, the empty set is considered a subset, and the set containing A, which is the same set, would be considered a subset. So there's one, two. It looks like there's two subsets, right? So if I have one element, then there'd be two subsets. If I have a set with two elements, let's list all the subsets. The empty set is a subset. The set containing A is a subset. Set containing B is a subset. And the set that's itself, AB, would be a subset. It looks like there's one, two, three, four, right? So if I have two elements, four subsets. And then you could do the same thing if you have three elements, right? And I list them all right here. We got the empty set, we got set containing A, set containing B, set containing C, AB is a subset, AC is a subset, BC is a subset, and then itself is a subset. There's 8 of those, right? Maybe you could see the pattern here. So the pattern is if I know the number of elements, so let's go with 4. If I have 4 elements, I'm not going to write them all out. It'll take a while, but the number of subsets would be 2 to the 4th. 2 to the 4th. So number of subsets would be 2 to the 4th. 2 to the 4th. In other words, 16. That'd be 16 subsets, right? So if there's 3, it's 2 to the 3rd. 2 times 2 times 2. That's why we have the 8, right? So that's the number of subsets. Now, if you're looking at proper subsets, that just changes it. There's only one change there. There's only one less because it can't be itself. So, for example, if you've got 2, right, the number of subsets, if there's 2 elements in the set, it'd be 2 squared. So you have 4, right? 1, 2, 3, 4. But you can't count the one that's itself for a proper subset. What's proper subset? So proper subset, there's 2 to the n minus 1. There's just one less, so 3. 2 squared minus 1. 4 minus 1 is 3. 1, 2, 3. There's 3 proper subsets, okay? So number of subsets is 2 to the n. Number of proper subsets is 2 to the n minus 1. You just have one less, okay? So let's find the number of subsets and the number of proper subsets. So the number of subsets here would be 1, 2, 3, 4, 5. There's 5 elements. So 2 to the 5th, 2 times 2 times 2 times 2 times 2. Looks like we have 32. There's 32 subsets. How about the number of proper subsets? That'd just be 2 to the 5th minus 1. So 32 minus 1, so we got 31. Okay. How about this one? How many elements do we have in this? First of all, it's got to be a natural number, and it's also got to be required that it's less than or equal to 15, greater than or equal to 9. So if you were to list those, 9, 10, 11, 12, 13, 14, 15, 1, 2, 3, 4, 5, 6, 7. There's 7 of those. So the number of subsets would be 2 to the 7th. Let's see, 2 to 7, 2 times 2 times 2 is 128. So the number of proper subsets just be one less, again, because it can't be itself. So we just take out the one that's itself, we're left with 127 on that. All right, the number of subsets, and this is just a kind of a, hey, just FYI on this. Let's say we had, if you're thinking about the natural numbers, we know that if we were going to list natural numbers, we know this is an infinite set, right? It keeps going forever. And by the way, they refer to that as chemically infinite. Okay? There's a number assigned to this. The cardinality of this, the number of natural numbers that there are, in other words, the cardinality of this set, cardinality, the natural numbers, they've given this a name, and they call it Aleph Null. Aleph Null is the name of that. So it's the name of the number of natural numbers. Even though we know it's an infinite amount, we're going to give it this name, okay? So if you were to figure out how many subsets of the natural numbers there would be, we say, well, that's 2 to the Aleph Null, right? That's how many subsets that we have, 2 to the Aleph Null. So the number of subsets, and this of course is also an infinite number, right? But we know this is greater than the number, the cardinality of the natural numbers, or Aleph Null, right? So this infinite number is greater than this infinite number, because we know the number of subsets of that would definitely be greater than the Aleph Null amount, right? The cardinality of the natural numbers. So this Aleph Null is referred to as the smallest transfinite cardinal number in this hierarchy of different infinities. Okay, and transfinite just meaning beyond or surpassing the infinite. Right? So Aleph Null is the smallest infinite cardinal number, smallest of the infinities, if you will. Okay, just something to think about, kind of interesting. See you guys later. Thanks for listening, and see you next time.